Hey, welcome back to the tutorial. First thing I'm going to start with is actually make a class called board. So we're going to make a board class, and this is going to be our board. It could be 3 by 3, 9 by 9, 90 by 90. It's going to be scalable, okay? It's not going to be like a standard tic-tac-toe. You can make it any size you want. So we're going to have a class board, of course, and of course it's going to take in a certain size. So we're going to make this private val, and we're not going to change the size. It's immutable, so that's why we're calling it val n, and of course it's going to be an int, and this is going to be our class. So what I want to do right now is have just something that gives me the board itself. For example, var board, and this is going to be an array. And of course, it's going to have n types of arrays or n columns, and those columns are going to have n elements in them. So it's going to be array at n, that's the notation. Then we're going to have two curly brackets. We're going to have the array of columns now. So we're going to have array again of n. And this time, this array is going to contain a string. We're going to have a variable that represents an empty character that we can actually print with. So we're going to have a private val empty equal, and let's just make it 3 underscores for the sake of this example. And I want to make this private var board as well. It's going to be a private board. And I also want to have something that represents the number of moves we played so far. So I'm going to make a private variable. So private var move count equals 0. So it's going to be 0 at first. We haven't played any moves yet. Then I want to have something that represents the game state, whether it's finished or not. So I'm going to make a boolean. So private var game or is game over, and I'm gonna initialize this to false at the very beginning. And actually, let's not make this var private. Maybe we're gonna use it later in one of the classes, we'll see. But for now, we have a board initialized with the size, so it's gonna have n by n. So if we specify the size 3, it's gonna make a 3 by 3. It's gonna make 3 arrays of 3 elements. So it's a 2D array. We want to have a method that helps us reset the board whenever we start a new game, so it starts with the empty characters. And if that's the case, I'm going to make a method for that. I'm going to call this fun reset board. And of course, all this is going to do, it's going to redefine the board variable that we have here. So this is going to be board, so I'm going to reset it all to empty characters. And the next thing I want to do is actually print the board or display it on the console somehow. So I'm going to make a function called print board. And of course, we're going to have to loop through the 2D array. And the way we're going to do that is with board.for each, right? So for each row, we're going to call this row. We're going to do another iteration. Whoops, there's already curly braces. So what we're going to do is for each row, we want to, this row represents another array, right? So for each array in that row, we also want to iterate over it. So we're going to do row dot for each. So we're going to iterate again. And this time in each column, we're going to have an element. So we're going to have element that we're looking for, which is going to be a string in this case. And with this element, what we want to do is we want to print ln, and we want to print the element. Whoops. And of course, each time we print an entire row, we want to have a new line so it doesn't get jumbled up. So we're going to do print ln, just like that. And then at the very end, let's just print ln to separate board displays. So if you have multiple board displays, they don't want to be like, jumbled up on top of each other. Now let's make a main class or an app that we can run all this from. So I'm gonna go into source, and I'm going to do new file, and I'm gonna call this main. And we're gonna have a fun main method. So this is the main method that we're gonna run our program from. And what I'm going to do now is define a board just so we can print it and test it out. So I'm going to do private var board equals board. And I'm going to define this with 0 size for now. And then here I can just define it with any size I want. So I'm going to say board equals, board let's make it size 3, and then we're going to say board.print board, something like that. And then I'm going to run this class, and let's see what it actually prints out. And as you can see, it's printing out a bunch of stuff here. So it's printing this, so it's printing each. Okay, so there's something wrong here. We're just gonna modify the print board method right here. Okay, so it looks like I made a mistake here. This should be print, not print ln. I don't want it to print a new line every single time. So let's test it out. Let's see what happens. And now when I run it, you're gonna notice that it does print the lines together, but I want them to be more visible. So what I'm going to do is I'm going to go back to board right here, and if it's empty, what we'll do is I guess for now let's just print something like this. Let's do this, the vertical bar, and then I'm going to print the element, and I'm going to run the class again just to see how it looks like. Oh, perfect. Okay, so it doesn't look the best, but you can see visibly which row and which column are we looking at. Next thing I want to do is actually make a method that prints or puts the piece in the board in any position. So for that, we're going to make a method called fun place piece, and it's going to take a position of x and y. So I'm going to say x is an integer, and same thing with y. So this is going to be an integer as well. And then it's going to take the move, which is going to be a string. What I actually want to do is check first if the game is not over yet, then we want to place it. So if game, or if the game is not over, so if not is game over. And we're going to check if the place we're putting it in is actually an empty character. So if there's no X or O already. So if and the board at X and Y does not equal to, or equals to, sorry, equals to empty. So we want to make sure if that's the case. If that's the case, we're going to do board at X, Y is equal to move, just like that. So we're going to make it, and then we want to print the board, just like that. Okay, so that's how place piece will work. And we also want to make sure that we increment the move count. So move count plus plus. I'm going to go to main KT, and I'm going to say, you know, board dot place piece. So I'm going to place this piece at, you know, 0, 0, and I'm going to call this X. It doesn't really matter. I'm just testing it out just to see how it looks like. So now you'll see when I print the board, it will look something like this. And as you can see, the spaces are all jumbled up. So it seems like when I place the X, it's not the same thing as obviously 3 characters. Remember, our empty string is actually 3 characters. So what I want to do in board is with the print method, I want to make sure if the element is empty or not. So if element equals empty, so if the element is empty, just print it the way it is, right? Else, we want to print it another way, so we're going to place 2 extra characters right here. And if I run this again, I want to see how it looks like. And there you go. Now, in order to place a piece, we also have to make sure that the position we're placing in is a valid position. So I'm going to make a method just for that, call it is position valid. And it's going to take an X and Y coordinate. So I'm going to say X is an integer and Y is an integer as well. And this method is going to return a Boolean, so it's either true or false. That's going to be my return type, and all it does is return. So return, we're going to check for 2 things. If our X is between 0 and the n minus 1, so I'm going to say X in 0 until and then n, just like that. So this is exclusive, so it will start from 0 all the way till n exclusive, so it will not reach n. And same thing with Y. So I'm just going to copy paste this just like that, and that should be our valid position. So before we even not only we want to check empty and game over, we also want to check if the position is valid. So we're going to put this on the 2nd line, and on the 3rd line we're going to do and the is position valid, and we want to put X and Y just like that. and that should actually prepare us. So if the game is not over yet and the board, oh, whoops, I have to check if the position is valid first before I point it at the array. Okay, so that should be okay there, and these are the three conditions that we want to check for mainly. Then I want to have a method that helps me reset the game when the game is over. So I'm going to make a fun, or yeah, it's going to be fun reset game. And what I'm going to do in reset game is reset the board itself, so that's self-explanatory. Then I want to say is game over equal to false, so even if it's true I want to reset it back to false. That's the starting condition, and the move count is going to be back to 0. Okay, so this is my reset game function. It should help us when we want to reset the game. Now we want to have another function that is going to be determining if there's a winning move. And this one's going to take an X and Y and the move itself. So just like place piece, it's going to be similar. So I'm just going to copy paste this. And it's going to also return a Boolean because we want to know if this is the winning move. Now, this logic is going to be long, but it's going to be very easy to understand. I'm going to explain everything in detail, how to determine the winning moves. Now, to explain this logic, I'm going to use our good old trusty Photoshop. It's a horrible painting, but bear with me here. So first, we want to check if the row is a winning row. There's going to be different possibilities, right? So for example, if you want to check this row right here, so this whole thing right here, what we're going to do is going to check if this is an X, if this is an X, and if this is an X. So if they all contain the same character. So we're going to go back to our editor and we're going to check the row first for the same character. So we're going to check the row, right? So we want to say for I in 0 until n. So we're looping till n exclusively. What we want to do here is if board at, and we want to check the same row, right? Which means the column is going to be a variable, okay? The column is going to be a variable, the row is going to stay the same. So we're going to say board at x, so it's going to be x row, the same row, at I, so this is going to be the changing column, does not equal to move. So if any of the columns are not the same, so if this is an X and this is an O, for example, it's going to loop through all these three columns, right? So it's going to check the first one, that's an X, right? It's going to check the second one, it's going to be an O, it's going to break. So that's exactly what we're going to do. So in that case, if it's not equal to move, we're going to break, right? If it's not equal. And then in here, if we didn't break from this loop, we want to check if I is equal to n minus 1. So if we didn't break yet and we reached the end of that column or to the maximum size, we're going to see if I is equal to n minus 1. So if our size is 3, n minus 1 is going to be 2, and I is going to go from 0 to 2. If those two reach each other, it means all the characters that we encountered so far were all the same. So if that's the case, I want to return true. Okay, so we check for the row. The other thing we want to check for is the column itself. So let's say you have the same tic-tac-toe 2D array. This time we want to check this right here. So maybe we're in this column. We also want to check if it has, you know, the same letters. So I'm going to go back to my editor and I'm going to check the column. And this is going to be the same thing, but just slightly different. So I'm going to do for I in 0 until n if board. Now remember, our column stays the same, but our rows change. So if board at I, because the I is the variable, and then y does not equal to move, we're going to break. And then if I equal n minus 1, So if we reach the end and we didn't break yet, that must mean that all the column elements were the same, and therefore we have a winning move. So if that's the case, we're going to return true. So for the diagonal, this is going to be 0, 0 right here. This is going to be 1, 1, and this is going to be 2, 2, right? Because we have 0, 1, 2, 0, 1, 2, like that. To check for it, you have to make sure that both x and y positions are the same, and then we do the same regular check, but this time both x and y are progressing, so they're becoming 0, 0, 1, 1, 2, 2. And in terms of code, this is what it looks like. So we're going to say check the diagonal for I in 0 until n if board, whoops. So first, before we even loop, we want to make sure that x is equal to y. That's the diagonal case. So if x is equal to y, it's a diagonal, and we want to loop now. So for I till n, if board at I and I, remember both of them are variable now, the row and the column, are not equal to move, we want to break. And like usual, if, I'm going to actually just copy paste this, same thing. If I equal n minus 1, return true, we have a winning move. For the anti-diagonal case, it's going to look something like this. And notice here, we can just easily check if x is equal to y, because in this case, the row and column are not the same. Here it's the same, but here it's not. Instead, the summation of the row and column is going to be equal to the size or the position that they're going to be in. So I'll explain why. In this case, look at it. So we have 0, 1, 2. So this is 2. So this is in row 0, column 2, right? The formula for this is, notice how x plus y position, so this is 0 plus 2, so it's going to be 0 plus 2, because it's in row 0, column 2, is equal to 2. But 2 is equal to n minus 1, right? Because this is a 3 by 3 matrix, as you would call it, and n minus 1 is equal to 2. It's the same case in the middle here. So notice how this is row 1, column 1, which is equal to 2, and that's equal to 2. So 1 plus 1 is equal to 2, right? And in the same case here, we have column 0, row 2. So 0 plus 2 is still equal to 2. So the general formula for the anti-diagonal is x plus y, which is the x position, y position, equal to n minus 1. If that's the case, that means we have an anti-diagonal. We're going to say if x plus y is equal to n minus 1, we're going to loop again. So we're going to go for I in 0 until n, and we're going to say if board at I. Now notice how they're like going this way. So in this case, it's going to start from 2, 1, 0. So that's the column. It's going to go 2, 1, 0. It's going to decrease. And to represent this in code, this is what it looks like. So we know that the columns are decreasing. So how can we represent it here? Well, we can say something like this. We can say n minus 1, which is the size of the array minus 1. So that's our limit, right? Because we're dealing with arrays. N minus 1, which is going to be the 2. So n minus 1 is going to stay constant. The only thing changing is I. So at first, n minus 1 minus I is going to be 2 minus 0, which is 2. When I is equal to 1, 2 minus 1 is equal to 1. So we're going to get to column 1. Then when I is equal to 2, 2 minus 2 is 0. So we're going to get to column 0. So our columns are decreasing on each iteration. So n minus 1 minus I. So that's our second, or that's the column position that we want to be in. And if that's not equal to move, we're going to break. And of course, if n is equal and minus 1 is equal to I, we're going to return true. So this is a winning move. And if none of those are true, we want to return false. And that's our winning move method. So I'm going to have a function called funIsDraw. And this doesn't take any parameters really. This has to do with the number of moves we played, so it's not going to take anything. And it's going to return a boolean. And we want to check, so we return, and what we want to check for, we want to check for the number of moves. So move count is equal to n dot to double dot power. So we want to square it, right? Because it's a 2D array. So if we have n is equal to 3, that means the size of the board is 9. So to the power of 2 minus 1. And of course, this is a returning double. So I'm going to convert this to an integer to int like that. And that should cover it. So what we're saying is, if you have a board of size 9, you've made 8 moves yet, and no one has won yet, that means it's going to be a draw. Okay, that's the general rule to this. So if we made 8 moves and we have a board of size 9, automatically the game is going to be a draw. There's no more moves to play. Now let's go back to our place piece method right here. And I want to expand on this now. Now that we have the logic for the winning move in a draw. So I want to say is game over equal is winning move x, y, and then move. Remember, they take the same input. So is game over or is draw. The next thing I want to check, if it's draw, I want to just print something to the screen. If it's a winning move, I want to also print something to the screen that determine it's a winning move. So I want to say if is game over and not is draw, so we know for sure it's a winning move in that case. Then I want to print ln winner, I don't know, chicken dinner, right? Something like that. Else, or else if is draw. So if it's a draw, I'm going to print draw. Okay, so now that we have our basic methods in place, I think we're ready to go to the main method and just test some things out. So the first thing I want to do is I want to have a scanner actually. So I'm going to have var scanner, or val actually, val scanner equals scanner, and I want this to be a user input. So I'm going to say system.in, and I also want to have a string that represents the current player, player X, and player O, and this could be anything really. So I'm going to go and say, private const, val, or not const, private val player 1 is equal to X, private val player 2 is going to be equal to O, and private var, so this is going to be changing, current player is equal to just empty string. We don't know who's the current player yet. And I want to make a method for that. So I'm going to say private take turns, or not private, sorry, fun take turns, then current player is equal to if player 1, if current player is equal to player 1, I want to make it player 2. So current player equals player 2, else current player is equal to player 1. Oh, whoops, this should be player 2 without any assignment really, and this should be player 1. So that's how you take turns. If it's player 1's turn and you say take turns, it will be player 2, and so on and so forth. Next thing I want to define is the size. So that's going to be a user input. So I'm going to say val size equal. I'm going to take a next line and just parse it. So I'm going to say integer dot parse int, and scanner dot next line. So that's going to be our size, and I just want to have a message that, you know, tells us something. So println, please enter, whoops, please enter size of your board, and we're going to enter the size of the board, and then our actual board is going to be a board of size, so that's going to be our size. And I just want to see what this looks like so far, just to see nothing's breaking down. So if I run this, it's going to, okay, please enter size of your board. I'm going to enter 4, and bam. Okay, so we're going to check if the game is actually over or not. So we want this to run in an infinite loop type of thing. So while the game is not over, you know, continue playing the game. So we're going to say while not board dot game over, like that. So while the game is not over yet, I just want to test out if I take turns, it's X's turn. So I want to say take turns, like that. And then I want to print ln. I want to say, you know, current player's turn, something like that. I just want to test this out, see what it looks like. So if I run this, actually, let's see what happens. It's going to be an infinite loop, I know, but so if I enter 3, hit enter, it's going to say XO's turn, XO's turn. It just keeps taking turns. So that's working fine for now. Okay, so next, how do we want to structure this or take input to know which position we're playing? I want to keep it simple and just take a row and a column and, you know, display it on the board. So for example, I'm going to say println enter row number, like that. And I'm going to say, you know, var row equals integer dot parse int, and this is going to be you know, scanner dot next line, something like this. Then for the column, I'm going to do the same thing. So I'm going to say println enter column number, and this is going to be the column, and scanner dot next line, same thing. Then I want to place a piece depending on the row and column. Now I want to translate this in a way that is more human friendly. If someone wants to put at position 3 and 3, it should be here, even though in computer science we start from 0. But for a normal user, someone who's not into computer science, they think that this is 1 2 3, this is 1 2 3. So whatever input we get from the user, we want to subtract 1 from it, and that's going to be our position. So to do that, I'm going to say board.place piece, and it's not going to be row, it's going to be row -1, column -1, right? So to avoid the index out of bounds exception. And then we're going to put player or current player. So remember, at the beginning, it's going to take turns. It's going to be X's turn. You're going to place the piece at that position, and now let's see how it works. So if I run this, actually, let's see what it does. So if I run this, okay, please enter size of your board. I'm going to put 3, and now it says X's turn, enter row number. So if I put 1, row 1, column 1, it's going to place the X at 0 0. Do you see what I mean now? It's more intuitive for non-computer science people. So we're going to place X at that position, and now let's test, you know, let's test the winning condition. Let's say we put 2 and 2, like that, X's turn. So let's say you know, row 1, column 2. So row 1, column 2. So now we have 2 X's, and now it's O's turn. So it's going to be, you know, let's say 3 and 2, like that. And then it's going to be 1 and 3. Winner, winner, chicken dinner, X wins. Now currently we're ending the game, but we also have the option to keep going if someone wants to play again. So if that's the case, I want to say, you know, if is game over. So if board.isGameOver, we want to ask the user if they want to play again. So we're going to do println, do you want to play again? Whoops. Play again. Whoops. Okay. Type y or yes. And then the answer, so var answer, is going to be equal to, actually, you know what? I want to make this a global variable. So let's make this private var answer equals that. So our answer is going to be blank at first. Then the answer is going to be equal to scanner.nextLine, just in case we need it somewhere else. So that's our answer. Next, we want to have a method that resets the game when they answer yes. So if that's the case, I want to, let me make a method here. So fun is playing again. Let's just call it that. And it takes in an answer, which is a string, and it returns a Boolean. And it's pretty straightforward. If it's y or yes, ignoring case, they're gonna play again. And this should be again like this. Okay, so return answer dot equals y, and ignore case, yes, we're gonna make that true, or answer dot equals yes, and ignore case also true. And that should be our method. So if is playing again and then answer, what we want to do is say board.reset game. So we want to reset the game and we want to play again. Okay, let's test this out. Let's see how this looks like. So if I run this and enter the size of the board, okay, that's 3. That's good so far. It's X's turn. Let's just put it position 2 and 2. Let's put it right in the center. O's turn. Let's put it 1 and 1. Let's put 2 and 3. So 2, 3, like that. It's O's turn. I'm gonna put 1, 2, like that. And then for X, I'm gonna put 2 and 1. So 2, 1. And look at that, it's gonna say there's a winner and do you wanna play again, yes or no? If I type in yes, let's see what happens. Now it's O's turn. So O will start the next game. Now it's up to you, really. You can make them so that they take turn. It really doesn't matter. You can take turns whenever someone wins or keep the same winner. That depends on you. But for now, we're just taking turns after each game. So now it's O's turn. Let's enter a row number. So let's do 1, 1. And look at that, it actually reset the board because we called board.reset. We reset the moves and we reset everything pretty much. It's pretty basic. I actually got this algorithm, where is this? So if I go to board.kt, this winning move is actually not the fastest. I actually got this from Stack Overflow, this logic here. It's the simplest case, just to explain to you guys how it's working. Obviously, as you advance as a programmer and you take algorithms and data structures, you're gonna find much more efficient methods than this, and in terms of time complexity and space complexity. But for now, this is just simple and gets the job done. I'm gonna link the answer for the Stack Overflow question down in the description below. But I hope this tutorial helped you guys, and hope it was fun and you learned something from it. I learned something from it because I'm literally learning Kotlin as I'm teaching this to you guys. So I really had fun doing it, and yeah, hope you enjoyed the tutorial. Please give a like or thumbs up. It helps me out, and subscribe to my channel if you want to see more content like this, and I'll see you guys next time. Peace.